Hello, everyone. We are going to talk also about Mamba. Yes, the snake Mamba. Or more precisely, we are going to talk about modular attention-free memory-based architecture, which is a machine learning architecture loosely named from the snake Mamba because of its speed, agility, and also how deadly it is. But this is machine learning, so we are going to talk about modular attention-free memory-based architecture. All right, I'm going to provide you a quick explanation of the model or of the architecture and also how it relates to other models out there. And also I'm going to show you a sample code snippet and I'll give you a quick explanation to show you what Mamba really is. Now, I want you to know that Mamba is part of the new wave of models that are built on structured state space models, or simply SSMs. Traditional transformers like GPT, they relied kind of heavily on attention, which scales a lot when we have long sequences. However, SSMs like Mamba, they aim to process long sequences efficiently without issues of attention. So they perform better with long sequences. They don't have to worry about attention. Now, before we even come to Mamba, let's talk about other preceding models or models that are out there that are kind of a building blocks to Mamba, to where Mamba is. Let's talk about recurrent neural networks or simply RNNs. Let's talk about LSTMs or GRUs. Let's talk about transformers. Now, if you go back in my timeline, there's a video or a hands-on code along project on recurrent neural networks. There's also another video on hands-on code along project with the real-life data set on long short-term memory or simply LSTMs. But now, RNNs and how it is related to Mamba. Now, recurrent neural networks or RNNs, they were early models for sequence, but they really struggled with long-term dependencies, long-term sequences. Now, because of that, short-term memory or GRUs were introduced. They improved a lot when it comes to memory handling, but still they were limited extremely when it comes to long-term sequences. Then there was introduced transformers. Transformers kind of changed, or I would say revolutionized, the whole concept of natural language processing, or NLPs, by replacing recurrence with attention. So they were great on context, but heavy on long-term sequences. Just like your ChatGPT. Sometimes it loses context, it loses attention when your conversation becomes longer and longer. So that was the problem with transformers. Now, because of that shortfall, there come the introduction of Mamba, or basically SSMs, which specifically in the year we're talking about Mamba, which try to combine the efficiency of RNN-style models with the flexibility of attention like operations that comes with transformers. So basically, Mamba in layman terms is like an information conveyor belt. Information flows through a state that gets updated step by step. Then Mamba uses I would call a selective state space update, meaning it can choose which parts of the state to focus on and which part of the state to ignore. Basically, on this part, it do exactly like long-term short memory. It chooses either with the open, the forget get, the keep get, and all the other gets. It let go information that is not necessary and keeps attention to core information that is related to the problem at hand. So this kind of selective mechanism, it allows it to able to handle very long sequences efficiently. It allows it to be dynamic. It focuses on important patterns and ignores all the noise. But however, unlike transformers, which kind of looks at everything at once via attention, Mamba remembers the essential parts of the past in a structured way. So basically, when you are going to basically I gave you how Mamba is related to other models out there. But basically, your Python code, when you're coding using the Mamba architecture, you have to define your model, your input sequence, and also the forward pass. That's basically the three key steps in your code. Okay, so I have given you kind of a more practical Mamba example here. So in our case, what we do is we want to import PyTorch. We want to have our module neural network. Then we also want to import from Mamba. Want to import the Mamba layer. All right. So now X here is a batch of sequences, like small time series of data, whatever you have. Then Y here is the target sequence we want the model to predict, basically the next number in the sequence. Okay, input sequence and the target sequence. Now we need to define our Mamba model. So we have Mamba predictor here, which is a small neural network that uses Mamba. We've got Mamba layer. Mamba layer here is there to handle the sequence using selective state updates. Then we have this FC, which is basically a fully connected layer, which converts the internal Mamba state into predictions for each time step. Yeah. Then we have our forward pass here. Now, Mamba processes the sequence. It updates its internal memory for each step. It kind of keeps that, it keeps attention to the real data that it wants. So it uses the forward pass to update its internal memory for each step that you take. Then we have our predictions. Basically, it maps the memory to the actual predicted value. Of course, you need to initialize and train your model. Then you come up with, you print out the result. Basically, that's the structure, the practical structure of a Mamba architecture. What I'm going to do here is I'm going to give you real world data, and we're going to do a code along video on the Mamba model so that you can have a hands-on practical example that you can put in your machine learning portfolio. Cheers, bye for now.